Okay, so I'm here with Professor Terri Hildebrand, and I would like to ask you, what are you going to be presenting to us today?
Today I'm going to be presenting on how to build a learning scaffold, and particularly how to build one that deals with scientific writing.
So why did you decide to create this series of assignments, or why did you decide to teach the scientific writing process in this way?
I decided to teach the scientific writing process in this way because students don't know how to write scientifically. They haven't been exposed to it by the time they come to school. And on top of that, I can't really teach it in lecture because lecture has to focus on content. And so I designed my general biology lab for teaching scientific writing and scientific presentation. So it's a multi-step process, and students learn how to write sections individually and put the sections together. I think more importantly, students are given examples, they're given checklists, they always have the opportunity to submit a draft, and they always receive feedback. They receive feedback on the draft, and then they receive feedback through the rubric. And so they actually don't write a complete manuscript until the very end of the semester. But up until that time, they write portions of a manuscript.
Have you noticed anything about how students learn, or do students learn better this way? Have you had good results with this, or have you had success with this method?
So I feel like students have had great success with this method. There's a couple of reasons. One is student apprehension about writing a scientific manuscript is very high. And by doing it in this step-by-step process, I take that away. They still learn how to write. They still get lots of feedback. And I personally can see an amazing difference from the first paper they turn in until the last paper they turn in. Students go on in my classes to write more manuscripts, and they seem better prepared to do it. I began by determining my key objectives for the lab. Biology lecture focuses on content. In contrast, my labs are designed to reinforce a subset of major concepts, such as cellular respiration, using the scientific process of discovery. The primary objective of my biology lab is to teach students to write and present investigative research. Because I narrow the content covered, this approach allows 3 lab periods for each topic. In week 1, the topic is introduced and students perform an experiment. For example, enzyme activity in potato tissue. They collect data using the methods provided. In week 2, we go through the steps of analyzing and presenting their results from week 1. In addition, students design an original experiment that use the same methods. For example, enzyme activity in fresh fish liver versus heart tissue. And then lastly, in week 3, students perform their original experiment and are assigned their first brief manuscript. To teach how to write a manuscript, I developed a learning scaffold that builds on each task until students have accomplished writing a complete paper. Key features of scaffolding are that students are provided detailed instructions, checklists, and examples before any writing ever takes place. Examples are used to teach students how to read a manuscript, as well as write a paper. Brief manuscripts allow students to learn 1 to 2 sections at a time to reduce their apprehension. Opportunities to submit drafts for each manuscript exist, and I provide detailed comments on these to increase student learning. And finally, a rubric is available for students to see precisely how their writing is assessed. Let's look at each step in more detail. The scaffold begins in week 2 with the lab handout that contains reference information. Students are expected to use this document throughout the semester, as well as for their first scaffold assignment. Students learn the sections of a scientific manuscript. and that these sections are the title, abstract, introduction, methods, results, discussion or conclusions, and works cited or references. In this course, students do not write abstracts. Examples of citations are included, emphasizing formatting in the works cited section, as well as in-text citations. Several pages provide a detailed list that provides step-by-step checks. Students are encouraged to consult this checklist as they write their paper, as well as prior to turning in their final product. A discussion on analyzing results introduces descriptive statistics and hypothesis testing with a focus on mean and standard deviation. Students learn how to conduct a t-test. Examples are provided that include stating null and alternative hypotheses, how to perform the test in Excel, and the interpretation of results. The Week 2 document also includes information on how to make graphs, including placement of error bars and their figure legend, as well as how to make tables and where their legends occur. And again, there are checklists for figures and tables that provide further guidance. The last section of the Week 2 lab exercise document includes an assignment that teaches students how to read a scientific manuscript. Students read section by section, answering questions that test comprehension of formatting as well as the topic presented. With this reference document in hand, students are given very specific instructions for writing brief and complete sections of a manuscript. All sections are always included in each manuscript, but the extent to which they are expanded varies. The next layer of the scaffold is laid with the assignment of the first brief manuscript, a paper with 2 complete sections and 3 brief sections. Recall, students may submit a draft and receive feedback prior to submission of their final product. A detailed rubric is used to assess all components of the manuscript, with adjustment for brief sections in italics and complete sections that include italicized and non-italicized components. The scaffold extends higher with the assignment of an exercise in which students write citations from a literature search on papers of a topic that interests them. Student learning grows with the next layer of the scaffold, a manuscript that includes another complete section in addition to a works cited or reference section. And finally, the last manuscript has all sections completed and includes a total of 6 references. Structural reinforcement continues throughout the student's academic career and culminates in the evolution course, where students take on the role of reviewers, reading proposals that have been submitted by their peers, and writing an essay that examines each component of the scientifically written proposal.